Muted.
Thank you for joining the webinar today on cyber defense for utilities. I'm Lauren with Pulse Supply, and also joining me today is Dave Thomas with RAD. Today, our discussion will focus on cyber threats to utility companies. During the presentation, if you have questions, feel free to type them in to the GoToWebinar control panel. We will read them aloud and respond as we go. If we've moved to a different slide or we miss your question, there will be a chance at the end of the presentation to ask questions. So let's get started. During today's 45-minute presentation, we will provide a brief introduction of our companies and talk about cyber threats to automation networks. We will discuss NERC-CIP, the different versions and basic guidelines. We will talk about network equipment requirements and distributed SCADA defense. And finally, we will discuss encryption. For those of you who may not be familiar with Pulse Supply, we were founded in 1995 as a distributor of connectivity products, and by the late 90s we began working with utilities and carriers to provide TDM and IP hardware. RAD is one of our key partners in this area, and we've been solving network challenges with their products since we opened our doors. Our goal today is to provide information to you that will be helpful and offer solution ideas that allow the new technology that is available to operate with the infrastructure you already have, helping stay within budget. If you would like more information about Pulse, our background, or capabilities, I can provide that at the end or follow up after the call. But for now, I would like to hand the presentation over to Dave Thomas with RAD. Dave.
Thank you, and thanks to everybody who joined today. So just a little quick introduction as to who RAD is, for those of you who might not know, right? We were founded in 1981. We're a privately owned company with 1.2 billion in revenue. We have 31 offices with sales channels in more than 150 countries, and with 1,200 total employees. So we're going to talk today specifically about cyber threats and what that means to not just power utilities, but to water, gas, even anyone basically that operates a private network. So we'll talk a lot about NERC-CIP, and NERC-CIP is specifically designed to address the needs of power utilities. But since it seems to be basically the best, or at least the best attempt so far at setting out guidelines for cybersecurity, we'll make quite a few references to it today. And we find a lot of water and natural gas utilities that use NERC-CIP as a guideline. Everybody sees the news. Everybody is aware of basically our infrastructure, our critical infrastructure, especially the electric power grid, being under attack by hackers. So, the Department of Homeland Security has specifically come out and acknowledged that China, Russia, North Korea are actually sponsoring attacks on our power grid. So what is NERC-CIP? I mean, for those of you who don't know, NERC is the North American Electric Reliability Corporation. They basically are responsible for setting guidelines for electric power utilities in North America, not just the United States, but all of North America, U.S. and Canada. CIP is the critical infrastructure protection. So basically this represents guidelines that electric power utilities have to follow when it comes to securing their power grid. Version 5 deals with the bulk electric system. Basically, the bulk electric system is a designation that was developed by NERC, and essentially it addresses any assets or any part of the power grid above 100 kV. NERC can basically conduct an annual compliance test with the power utility, and beginning in 2016, they can impose fines for anyone who's not compliant with version 5. Version 6, and actually the latest news is version 7 is being rolled into along with version 6 This will come out in 2017, and it'll actually include low impact or the grid that's below 100 kV, and then also transient devices, and this could be devices that power utilities move around their power grid, distributed generation, power quality monitoring equipment, et cetera, right? But it'll address those and how communications to those has to be secured. So if you looked at the document, I mean, it looks a little bit like this. What we as telecommunications professionals are most interested in are section 002, which are the critical cyber assets, and 005, which is electronic security perimeters, and then 007, which is the system security management. We'll talk a little bit more about what that means, and I promise you, this is a very difficult topic to discuss in under 45 minutes. But I'll do my best to kind of hit the high spots, and hopefully it'll provide some useful information, and we can at the end we can answer any questions or create a dialogue. So if you look at the terms, I mean, you're going to find out that in NERC, huge number of new acronyms, and I'm sure most of you are like me. I mean, it seems like every day of our life we spend addressing or looking up a new acronym, or we're confronted with new acronyms. But when you look at the NERC-CIP documents, one of the first things you're going to see is BES, which is the bulk electric system. Again, we discussed that just a second ago on the earlier slide, but basically that's everything above 100 kV. We look at we'll talk about BCS, which basically is the BES, or bulk electric system cyber system. And essentially, even though it sounds kind of, you kind of sound like you're talking about a science fiction movie here, but essentially this is cyber assets that are grouped and are basically assigned to perform a specific reliability task for the power grid. Bulk cyber assets. So these are programmable electronic devices that are part of the cyber system. I mean, these could include hardware, software, and the data that's stored in those devices and that are critical for electric supply and or electric supply reliability, or making sure that the power is delivered 24/7, right? I mean, and again, while we're talking about NERC, and it applies very specifically to electric power utilities, all of these things that we're going to discuss really apply to water and power and our water and gas, et cetera, power utilities. Also, we'll talk about ESPs, which are electronic security perimeters. These essentially are just kind of an electronic boundary that surrounds the cyber assets, so they're sort of an imaginary line. The BROS, which is the bulk electric system reliability operating service. You'll hear a lot of power utilities talk about bottom up or top down. This is this is kind of brought in by NERC-CIP, and essentially even though sometimes it can be kind of confusing as what they mean, but it's real simple. I mean, if they do a bottom up methodology, then they have to go out and identify all their cyber assets, and then work up to how those cyber assets would fit into cyber systems and reliability operating services. Or they could do a top-down and essentially start with reliability operating services and work down to cyber systems and cyber assets. You'll hear some new terms, or not old terms, but in kind of new context. You'll hear things like programmable inside the NERC-CIP doc, and affect the reliable operation of the bulk electric system. And essentially, NERC doesn't really define what these mean. It's up to the power utility to define them. And it actually puts a lot of onus on a power utility to identify all these cyber assets and cyber systems and reliability operating services and where they're at. And then once they've identified them, then they have to identify how they're protecting them and be prepared to defend that but when they're audited. And then you'll hear medium impact versus low impact versus, sorry, it should have high impact in here also, but essentially some of these cyber assets and cyber systems will fall under what's considered medium impact or high impact, and specifically version 5 deals with those. Low impact, if they fall into low impact today, there's no real guideline as to what needs to be done, but that will come again when we see the version 6/7 come out. And then of course there's a link here if you want to go and look at some more of these acronyms and what they mean, and at least kind of brush up on what power utilities are going to talk about and what you may hear in different meetings. One of the things that NERC-CIP specifically version 5 brings out, it talks about external routable connectivity, and it makes very clear distinction if you have high impact or medium impact cyber systems, and if they have external routable connectivity, or if they don't have external routable connectivity, how security needs to be addressed. But essentially, as we all know, a routable protocol is one that employs both a physical and a network address, so a MAC and an IP. It's a kind of a common misconception, and NERC warns power utilities that just because a cyber asset's connected over a TDM network, so whether it's connected over SONET or T1, it isn't necessarily exempt from electronic or external routable connectivity. So keep in mind that if you're using protocol converters, they could have IP addresses, and even though they're being transported over a TDM network, there's still an IP address that's assigned to that protocol converter that can be accessed and remotely and used to basically, you could spoof it or turn it off or change the settings or whatever on it. So it has to be protected, and it falls under this external routable connectivity rule. So ESP, the electronic security perimeter, essentially, like I said, it's really, you have to think of it in terms of, I like to define it as it's an imaginary fence. So it's essentially all the devices that are considered cyber assets or cyber systems would sit inside this electronic security perimeter. The electronic security perimeter is going to have access points, and it could be a single access point or multiple access points depending on how their networks are configured or how they communicate to an electronic substation. But essentially what NERC says is that the responsible entity shall ensure that every critical cyber asset resides inside an ESP, and then they have to identify and document the electronic security perimeter and all the access points to the perimeter and all the cyber assets that sit inside of the perimeter. So the first step in becoming, at least for a power utility, to become compliant with NERC-CIP is to essentially create this electronic security perimeter and document the access points to it, and then all the cyber assets that would sit inside of it. So PSP, so the physical security perimeter and electronic security perimeter networking equipment requirements. So essentially NERC-CIP comes back and says that, or comes out and says that malicious communication detection methods via application layer firewalls, including DPI or deep packet inspection technology, that monitor both the ingress and egress traffic should be employed. Device connection control. This is one that's a big challenge for power utilities because they have a lot of old hardware that it's difficult to block unused ports or even identify where those unused ports or unassigned ports are. But essentially, they have to create a document identifying all the ports in their network, and also don't confuse the word port with Ethernet ports. It could be a serial, it could be a USB. It's anything that would allow you remote access, would allow you access to reprogram or change settings. So those have to be identified, and then and we'll talk a little bit more about what NERC calls out, or basically what NERC says has to be done to those. But essentially, in a nutshell, you have to identify them. If they're used, you have to identify how they're protected. and if they're not used, you have to either turn them off or come up with a physical way to block them, or even at a minimum, NERC does give a little leeway in version 5 that if you've got unassigned ports that you can't physically turn off and are basically can't be blocked, you can place signage that says that these ports shouldn't be used. Now, not sure that's a great way to secure anything, but they are giving them some access because, like I'm sure most of you guys realize, there are devices out there that are very old, and trying to protect some of the ports on them is going to be next to impossible. It also talks about intermediate systems for interactive remote access, and interactive remote access is a big point of discussion inside NERC-CIP. So this is when they start talking about how engineers in a utility would remotely access, say, meters or fault recorders or protective relays to change settings or reprogram or check the status of. So that becomes an interactive remote access when they do that over a network. And then you can have an intermediate system that you put in place, and I'll kind of explain it in a few slides later, or a few slides in it that I'm going to come up to, what that actually looks like and what it means. But essentially, it would be a device that breaks the protocol, provides encryption between the intermediate system and external to the electronic security perimeter, the cyber asset that's sitting inside of it. It also needs to support multi-factor authentication. And then one thing, and I kind of added this to the slide a few months ago just because it's important, but one thing that NERC calls out for is you have to log everything. And for those of you who are familiar with syslogs and that technology, I mean, essentially, NERC is basically going to the utility and saying everything that you deploy, everything that you have on your network needs to have the capability of logging what happens to it, right? So anytime it's accessed, anytime it's changed, anytime someone tries to hack into it, I mean, they want you to keep logs of all that, and then those logs have to be made available if they're audited. So distributed SCADA defense. So I named this. I use this name on the slide simply because when you get into power utilities, gas utilities, water utilities, SCADA is by far the -- communications requirement. So they rely on SCADA to monitor their systems, control their systems, protect their systems. It's essentially the tool that they use to deliver their product, right? So, I mean, power utilities, water utilities, gas utilities are like any other business. I mean, just they have to be in the business of delivering a utility, so it's important for them to keep that system operating as reliably as possible because that's the way they earn money. So since SCADA is that big telecom requirement and it's so important, and if someone wanted to disrupt the power grid or the water system or delivery of natural gas, one of the best ways to do that would be to interfere with the SCADA system. So this table is actually straight out of NERC-CIP, and this kind of gives you an idea of what some of the NERC-CIP specific requirements look like. And I'll forewarn you, I mean, don't expect them to call out a lot of technology or standards or things like that, like you might, expect to see. But essentially, it's basically guidelines on what needs to be done, and it forces the utility to make a lot of decisions that about how things are going to get done. But essentially, it says the applicable systems, and now we'll get into some of these acronyms. But electronic access points, so EAPs, for high impact bulk electric system cyber systems, and then electronic access points for medium impact bulk electric cyber systems at control centers. So essentially what they're saying, that anything that's classified as a high impact, which would have a high impact to the reliability of the power grid, or anything that's classified as a medium impact, that would have medium impact on the power grid, but is part of a control center, has to have one or more methods, or if you look over the requirements, has to have one or more methods for detecting known or suspected malicious communications. And then it gives measures, and basically this would be an example of evidence may include, but is not limited to, documentation that a malicious communications detection method is deployed, e.g. an IDS or an intrusion detection system or application layer firewall has been implemented. So essentially what they're saying is for SCADA systems that fit these systems, I mean the high impact and medium impact control centers, which typically the SCADA systems are going to fall under that, or a lot of the SCADA systems are going to fall under that, then having firewalls is very important. Again, like I said earlier, we'll talk a little, we're going to get to this device connection control and what it means. And again, I won't read through all this, but you get the idea. But the applicable systems, it lists which applicable systems there are. I will note in the first one, in part 1.1, you notice the medium, it lists medium impact. But when it does medium impact, it says that it has external routable connectivity. It lists high impact and doesn't say that. So essentially what it means is any high impact cyber system, regardless of how you communicate with it, and any medium impact that is communicated with external routable connectivity or a network that uses external routable connectivity would have to have this requirement. And then it goes through and it says, essentially where feasible, you have to enable only the ports that are needed. And I won't go through and read everything in there. The document or this presentation will be made available later. But since we don't have time for me to sit here and read everything, but I'll just kind of scan over it. But essentially, what it's saying is that you've got to identify all the ports. Once you've identified those ports, you need to turn off the ones that aren't needed, or be able to block the ones that aren't needed. And then you also need to be able to log when those ports are accessed or when the ports get changed for whatever reason. You need to be able to identify that, log it, and have a record of it available if you get audited. And then also, obviously, if someone's changing the port, you want to know make sure that change was intended and not someone hacking into your network and trying to spoof one of your cyber systems. And then just a little document about a little thing about what some of it means. I pulled some of the language out of some of the NERC documents, but essentially, probably the second bullet there is the assumption is that anything that plugs into the network, so whether it's a PC, a camera, a switch, a router, a USB stick, whatever, right? If it can plug into an Ethernet port, a USB port, a serial port, or a wireless network anywhere in the network, it needs to be suspect until it's proven that it's not, right? And then obviously the risk there would be when these devices when these things are hacked. I mean, obviously now you're talking about worms or viruses or denial of service attacks, et cetera, that could go on and wreak havoc on a power grid or, again, a water utility, whoever, right? So we can all imagine what the impact could be. Intermediate system, what does that mean? I mean, we talked a little bit about it earlier. It can do a protocol break. It provides encryption. It provides multi-factor authentication. But essentially, it's a device that allows remote access to these legacy systems that are out there that may communicate over serial or even four-wire modems or Ethernet, but didn't really have security built into it. So an intermediate system can be put in place and essentially provide the security features that are known. And again, this gives a list of what those requirements are. And again, like I said, it's encryption is one of the key ones, multi-factor authentication. So now that you know who's accessing it and that they're accessing it from a location that's approved, and being able to do that, is going to be important. And then again, logging all of this, right? So all of this, anytime someone remotely accesses one of these, you need to be able to log it. So that's basically what the intermediate system, or what they call out for an intermediate system. And since this seems to be a little bit of, a lot of people have a question about, still what does it really mean? I mean, I kind of did this slide to show you a little bit about what it looks like, but you can see the red dotted line, which basically is the physical security perimeter as required by NERC-CIP. Inside that is the ESP, and then there's the non-ESP, but inside the ESP would be the high-impact cyber systems, medium-impact cyber systems, And then you see the yellow dot in the middle, which is an electronic access point for the ESP. So when coming off the network, you're connected to the electronic access point. It's an encrypted communication. Below that, you have the intermediate system. The intermediate system is providing protocol break, multi-factor authentication. It's logging everything, has an authorization server, and then it allows communications into the BCSs, so the high impact and medium impact BCS. So when kind of starting to wrap up here a little bit, when we start looking at what RAD does in this market, I mean, we're providing multi-service access multiplexers. Those devices built in have device connection control using 802.1x standards. We have built-in SCADA-aware firewalls using our NFV interface, our NFV platform. Inside the multiplexer, we can do intrusion protection, anomaly detection. We can do third-party firewalls or provide our own firewall. Man-in-the-middle prevention is a big thing in NERC-CIP version 5, and it's going to be even bigger in version 6. So we, in our carrier Ethernet platforms, we're providing MACsec. So those MACsec, we're using MACsec to do encryption, but also do integrity so that we know that every packet that goes across the network is authorized, and we know where every packet comes from, so we can prevent replays and things like that. And then we also have solutions at layer 3 that can operate over Ethernet, but also operate over 2G, 3G, and LTE, and they support basically the same features, but also from an encryption standpoint, obviously since they're layer 3, with the IPsec, and I'll talk a little bit briefly about what the difference between IPsec and MACsec. But essentially, a man-in-the-middle attack, what would that look like? So if you have a carrier network, if the utility is using a carrier network for communication, so they likely have an MPLS network, which the utility can't secure themselves, so they have, they can't guarantee it's secure. So what we're doing is setting up we're setting up a MACsec one-to-one security authenticated tunnel across that network. I mean, by getting a layer 2 cloud from the service provider, and essentially we use MACsec, and it can basically create that encrypted tunnel and guarantee security across even a service provider network. So a little bit about encryption. One of the things that NERC points out is that it needs to be one-to-one. So you need to have one-to-one encrypted tunnels, even over private networks, but especially over the public networks. And we won't go into a lot of detail. I'm sure most of you guys understand encryption and tunnels, right? But essentially, you identify point A, point B, and that's the communications for that cyber asset, and then you want to have an encrypted, authenticated tunnel between point A and point B, regardless of the network. A little bit about MACsec and IPsec and how it pertains to especially power utilities. A lot of you are aware that power utilities do a lot of applications in their network, especially for power quality and for protective relay or teleprotection that are very, very latency sensitive. So MACsec is what we use in our multi-service platform, and that's what we use for substation communications and specifically teleprotection or protective relay applications. IPsec has basically, it's a software-based encryption. It's a great encryption scheme, very well, very good protection, but it basically adds about 40% bandwidth overhead, whereas MACsec's much less. So in our multiplexer, when we deploy MACsec for an entire gigabit payload, we're adding about 8 microseconds of added delay. So very insignificant delay when we do MACsec. So we use MACsec specifically for teleprotection and substation communications. But we do employ IPsec in our layer 3 devices, and those devices mostly go into distribution automation, AMI backhaul, that type stuff, right? So in that case, the added overheads of no consequence to the power utility. And then just real quick, what a MAC-SEC tunnel looks like. I mean, essentially, we can build tunnels across network, across a ring, across another ring, and that ring could be the utility's private network or a public network. And we can also build MAC-SEC tunnels within rings. And essentially, if you look at the NERC-CIP directive and once they call out for encryption, it says essentially documentation of the configuration of interactive remote access for this ESP. The documentation should describe how encryption is employed for the interactive remote access session and the termination points of that encryption. So you have to identify the point A and the point B, and then identify how you've encrypted it. Network access control, we talked quite a bit about this, but I just want to show this slide real quick. This is a software product that we're implementing in our NFV solution. Essentially, it creeps out and illuminates every port in the network, and so it can automatically identify ports in certain products, and then it also allows provisions for the utilities to enter the ports that for maybe older devices that it wouldn't be able to identify, but it gives you a way to track those ports, identify what the status is, and then keep an ongoing log of what's going on with all of those ports that are out in the network. And remember, in the world of NERC-CIP, a port isn't just an Ethernet port. It could be a USB port or a serial port, anything that allows remote access or allows access to the programmability of a cyber asset. And then this is the NERC-CIP directive, and I won't read it all, but essentially you kind of get the gist of it. And probably one of the most important things is you have to document and be prepared to provide that documentation if you're audited by NERC-CIP. So starting to wrap up a little here. So when we look at RAD solution, in the top right-hand corner, you see our multi-service access multiplexer. That multiplexer has built-in firewalls. The firewall can be specifically SCADA aware, so it knows specific SCADA protocols, and you can literally it does deep packet inspection, and you can literally give it a whitelist of all the SCADA commands that are allowed, and also block all the SCADA commands that aren't allowed. We do encryption out across the network using MAC-SEC. We can do that whether it's over carrier Ethernet or IP MPLS backbones. We provide network access control, and we write everything to syslog, so they can keep an ongoing record of everything that's going on as far as all the available ports in the network. And then we provide a network management software package that allows them to manage all this going forward. So including doing the syslogging and firewall control. So summarizing, NERC-CIP, introduced a lot of new acronyms. I feel your pain if you're not real familiar with NERC-CIP, because all of a sudden you're thrown with if you set it in a meeting with a power utility, or if you're part of a power utility and you're discussing this, all of a sudden you're going to get inundated with new acronyms. But basically, the main thing that NERC-CIP calls out for is firewalls and firewalling for most all of your electronically secured perimeters, or ESPs. And also, I find most utilities are kind of doing the high watermark approach. So even though NERC-CIP says, hey, this is, you have to do this if it's a high impact, and do this if it's a medium impact, and don't do anything if it's a low impact. They also warn that future versions are going to increase those requirements even down into the low impact stuff. So a lot of utilities take that high watermark approach, and essentially they're starting to secure everything, put firewalls in everywhere. Encryption is a key part of NERC-CIP, and especially if you're going over leased networks. But even if you have a private IP MPLS backbone, I mean, encryption is going to be very important. Again, logging everything, and nowadays it's not some guy, some pimple-faced kid in his grandma's basement hacking into your power grid for fun just to see what you can do. I mean, we have countries that are sponsoring attacks on our power grid every day. And, you know, if you set it on some of the Department of Homeland Security presentations on cybersecurity for utilities, I mean, they don't hesitate to call this the next big weapon against the U.S., right? So if you want to attack the U.S., the best way to attack us is to hit our infrastructure. And so just a quick look at what RAD are offering, but essentially RAD provides both packet switched and TDM networks for operational wide area networking for utilities. We can do multi-service substation multiplexers, which can do not just SCADA and voice and networking requirements, but also can do teleprotection. We can duplicate the traffic either over Ethernet, carrier grade Ethernet, or over SONET T1 or T1. We do smart meter distribution and automation backhaul, and probably one of the fastest growing markets we see is distribution automation. We're doing a ton of projects in distribution automation. And then network management. We provide a single network management platform that's able to manage all of these products and all these features and essentially give a power utility a secure, cyber secure solution in one from a single vendor. So there's the key takeaways. Again, the presentation will be made available by Pulse afterwards. So if there are any questions, fire away.
Okay, Dave, here's a few questions that came through. One says, does NERC-CIP requirements only apply to power utilities?
So NERC-CIP only applies to power utilities, but one of the things that I find in working, I do a lot of work with water utilities. They follow NERC-CIP guidelines. So while it does just apply to electric power utilities, it's the content is applicable to water utilities or even natural gas utilities.
Okay. Another question that we have is, do these new NERC requirements apply now, or is there a future date to meet the requirements?
Okay, so currently version 3. If you notice, I talked a lot about version 5. So currently version 3 is enforceable. Version 5 is available, and the utilities have access to it today. It doesn't become enforceable until Q2 of next year. And then the following, which would be version 6, but now they're saying they're actually going to roll version 6 and 7 together, would be Q2 of 2017. So it's like I said earlier, it's an ongoing process. Today it's version 3, but today most power utilities are anything they're doing is to version 5, because come into Q2 next year, version 5 would be enforced. Right?
Okay. Next question is, can you really create a secure encrypted tunnel over a carrier-provided network?
You can, and RAD's recommendation is that you essentially need to get a layer 2 cloud service from a service provider, and then use MACsec, and you can create a one-to-one secure tunnel across a carrier-provided network.
Next question is, how about a 140-2 for communications?
140-24. Could someone explain? I'm not familiar with that one.
It was one of the questions that came in. The next question is, I am a generating station in Genoa, Wisconsin. My concern is for my plant and our approach as a low-impact BE cyber asset. My external connectivity is CEM and system monitoring. EAC is a concern. How does NERC-CIP affect me?
Well, if you're low impact, it doesn't affect you. it won't affect you in version 5, so you're essentially exempt until 2017. Now, version 6/7 will address low impact, and it depends on how you fall into that. So, but assuming you're generating, if you're generating enough power that your system operator, your ISO, thinks that you could, if you were taken offline, it could be impacting, then you're going to fall into version 6/7 and requirements there. And I would assume that, and I think it's safe to assume those requirements are going to look very similar to what I talked about today, right? So remote access is going to need to be encrypted. You're going to need to establish electronic security perimeters around even your low impact cyber assets. So that would be probably what you're looking at, right? But again, you won't know fully until we see what all's in version 6 and 7, right?
Okay, and back to the other question that you weren't sure about. It is about the 140-2, which deals with the federal standard FIPS 197. He wanted to know how you do for communications.
Yeah, I'd have to look it up. I'm not real familiar with that standard. I'd have to look it up and understand a little bit more about that standard. But I'd be glad to take it offline and get an answer back. Sorry about that. That's not a standard I'm real familiar with, so I'd have to see what all it entails, right?
Okay. The next question is, I work with various utilities to develop all hazards crisis management plans. Are there any issues with sharing company IT security posture with other company personnel who have been identified as having a need to know?
Yeah, I mean, absolutely right. I mean, and this kind of gets, inside the NERC-CIP guidelines, there are some guidelines about how that should be handled, but again, I think what I'm seeing most power utilities, I mean, they're taking, again, that high water mark, right? So, I mean, everything's a need to know, and, it's just even today, I mean, just in the last few months, I mean, we've signed NDAs with 2 large power utilities just to share information on what their current infrastructure looks like. So they're requiring RAD as a vendor to sign an NDA, right? And this is shared network drawing. So yeah, absolutely right. I mean, it's everything needs to be need to know and very, very controlled, and as far as distributing what your network architecture looks like, because that would be the first step. If someone wanted to hack you, the best thing to know is what your network looks like, right?
Okay, I think that's all the questions for today. I would like to thank everyone for participating, and we will randomly draw participants' names for the Kindles and notify the winners via email.
Again, thanks.